All right, we're recording now. Sorry, Logan. You'll just have to pick up a couple seconds late. The parts I get are step files, neutral, solid models. When they come in, they're just a body, no features. So suppressing those features in Mastercam, you still got like the model prep. You can go in there and you can use these tools to remove fillets. But do you see anything to remove chamfers? So if they put chamfers on all the edges, you can't get rid of them. Now, most of the time, the problem lies in the fillets, the vertical walls to the floors. That's usually where the chaining issues are issues, because the fillets get to like where this level, here you go, I'm going to zoom in on this. The fillets get to where this level blends into this level, and then you've got this weird little cusp right there that doesn't really have anything to kind of continue on from. So that being said, I'm gonna do this part real quick. I'm only gonna do like a little piece of it to show it to you. Hopefully my computer doesn't do what it did this morning. This morning we were doing this and it locked up like continuously. But I've reset it, I've updated it, restarted it, all the stuff, so it worked after that. So let me just kind of walk through this before we watch the next video. So when I'm machining this, my rule of thumb, and I would recommend this to anybody, is always, we want to use as much of the flute as possible. And I typically work from the outside in. Okay? So what that means is, like, just like this part is, the first thing they did was they roughed the outside, they got it all to there, and then they went ahead and they did the through features up here. That's okay, because there's a good chance, we might need to use some of these to hold this thing down on a fixture or something, or alignment. Like if I was really cutting this part, I'll just full transparency, if I was cutting this part, this would not be the first thing I did. Unless the part was like extra thick and I still had like, a half-inch material underneath supporting everything. Because as soon as I notch out all that extra material, if this thing's only got a little bit of holding, if it's, let's say it's an 1/8 inch thicker, that ain't much clamping on that thing, and they're going to get a lot of vibration as you're trying to machine the rest of the material away, right? I would, if I was making this part, truthfully, like depending on what the overall thickness is, which is 23 millimeters, so right at 1 inch thick, let's say they ordered 1 inch material, and that's what we're working off of. My thing on this part would be I'd do all the through holes on my flat plate, and then I'd bolt it down to a fixture plate where I've got all those through features gone, locate it and everything off that, and then machine everything else with it down on a fixture to support everything underneath. Okay, but we're going to roll with what they've given us here. So like I said, outside in, bottom up. We've got the outside done already. Let me go unselect this solid so it quits highlighting it. There we go. Okay. So like if I was going to come in here and put this next toolpath in, and let's just say I'm going to machine this step out here. The other thing you saw him do in the video is like he tied a bunch of stuff together and did a bunch of stuff at the same time. The next video we're going to watch it because it kind of shows you a little bit more of that. It's a shorter one, but it shows you like how you can do multiple features at once. I don't like that. I am very guilty of being the person in the past, and I've gotten away from it. I've broke this bad habit I had where I wanted one toolpath to just do it all. I wanted one toolpath to basically be like artificial intelligence. Here's my part, take this toolpath, select all the stuff, and I want it to figure it out and make it happen. Okay, trying to take too big of a bite at once. And there are, like, these toolpaths have the ability, it's not that they can't, it's you will spend more time trying to get everything dialed in to get it to do everything at once than what it would have took you to have 6 toolpaths that are just copies and paste of each other with individually out areas. Okay, so keep that in mind. Don't think you have to machine it all at once. Break it up. Break it up into 10 toolpaths if you need to. Mastercam doesn't care. It's software. It doesn't take that much. It takes actually probably less time to do it that way. And I'll show you, like I'm going to do this part and then I'm going to do 2 more parts real quick, because once I've got it dialed in, it's just a matter of reselecting the geometry and resetting my depth. Okay, so we'll do this step out here first, and we'll just go to dynamic mill here, and I'm gonna start out. You know, I'm gonna watch a little one on automatic regions. This part absolutely would not work, but machining region. Okay, what are we working with? Well, I want to machine this step over here. So bring this over here. I've got it in 3D and I've got it in the edges. And I'm going to build an edge that basically surrounds this island right here, this step. I'll start over here on this edge. Okay, and then I like to use the keys. So he talked about it, you may not have caught it, but I like to use the keys that kind of help these branches along the way. So the X key is going to drive me until I get all the way around to this corner right here. Okay, and I'm going to go one more. And I'm going to rotate this around so we can kind of look at this. And it does a pretty good job of kind of guessing what it thinks you might want to do next. Not every time. Sometimes you got to hit the adjustment, okay, which is J, to move that red arrow to the right edge that you want to follow. Okay, and if you zoom in and out, this is something I figured out too. When you zoom in and out, oh, that time it is. Sometimes when you do this, there we go, you lose the hotkey because you get clicked off. Like if I rotate it with my mouse key, I get clicked off of here. If it quits letting you make that, all you gotta do is come back over here and click on it again, okay? But then once I've got the red arrow where I want it, I can send it on around, get it back over here, decide, okay, you know, I'm not gonna zoom too far in because I can kind of tell this one's wanting to run here, but I really want to run down here, don't I? So I'll flip that edge and I'll hit the X key to close that loop. Like I said, Mastercam looks at it like that. So even though there's stuff that's doing this in there, it's looking at it 2D over the top. This is not a 3D toolpath, it's not a multi-axis toolpath. So the toolpath only can look at it from basically vertically from the plane that you're in. We're in the XY plane. So it can only look at it vertically from the plane we're in. So that's got, here's what I want to machine. I'll hit OK. I'm going to start from the outside of that. Now if I hit preview chain right now, we got a little bit of a problem because it's wanting to come from the outside over here, and when I generate that, it's going to cut over into that, and I need some avoidance, don't I? So I'm going to do the same thing with that. I'm going to say, okay, let's go select some avoidance. I'm going to use the same selection options, and I'm going to do this. I'm going to say, I'm going to use this edge right here. Okay. I'll drive that around the part here. Now, when I get over here, I could just do this part probably and not have to worry about it getting into any of this. But when I get that around to right here, then I got to go up and I got to kind of follow all those other features. So instead of continuing on this vertical edge here, what I'm going to do is, sorry. And if I give you a headache from spinning around too much, I apologize. What I'm going to do is I'm going to have this go down. Okay. And then I actually want to go down again here to the bottom edge of this part. There we go. And I'm going to shoot this all the way around the whole part. I'm just hitting the X key, which is the hotkey for that, until I get back over to here to bridge this back together. I gotta pay attention because if I go past this, I can't get back up to here, can I? So I want to make sure I get here, and then I need to go back up and then over and close it out. You got to drive it around. If you click one time if you like click one too many, there is no like just go back one step. You basically have to undo it and start the loop again. So it takes time. It takes patience. I didn't take time. You can do it pretty quick. And when you get good at it, I'm not good at it because I don't do it that way very often. I suppress and get rid of all the stuff. I don't model parts with all these features on them. Okay, I just don't. I suppress them. If I know I'm going to machine a part I will draw it in SolidWorks typically because I draw most of my stuff in SolidWorks. I'll draw the part in SolidWorks, but before I export it out to take it to my CAD cam, Mastercam, I suppress all the fillets, and I suppress all the edge fillets and all the chamfers, and then I export it out, and I bring it into Mastercam that way. And then I look at my print, and I know, okay, that needs a chamfer, that needs a fillet, and I work off my print. So if I hit preview chain now you can see what that's going to do. There's our outside, and there's that part. So we'll hit OK. I'll just kind of work swiftly here. I'm going to say let's use this big 20 millimeter bullnose end mill. We don't want to use the flat end mill because, well, if we do that, then we're going to cut our radius out of there, aren't we? So we'll use that. I'm not going to mess around with speeds and feeds and stuff because everything's in metric, so all that do is confuse everybody. This is not 2 inches. That means I need 50. Five. 3 should be fine. Top of stock. Tell it where the top's at. Apparently it is at -1. The depth we're going to go to is over here. 18D. Hit OK, and there's the toolpath just to do that island. Once I've got that, though, like I said, it's just a matter of copying it, selecting the geometry, moving to the next feature. The other thing I'm going to incorporate when I do these, when I'm roughing a part, I start using the rest mill. That way it's also, not only is it looking at what I select geometry wise, but it also will make sure I don't cut air. I don't recut something that I've already machined. So it helps it takes all the previous cut paths that are part of that toolpath group or that machine group, depending on how you've isolated them, and it utilizes them. So like if we take this and copy it, okay, and let's say now, this time, okay, we'll go into the toolpath and we'll say we got to get some new geometry. We'll start out with the machining region this time. We'll say, okay, let's go get that. And this time, let's machine this tab over here. Okay. I'll do the same thing. We'll say we're going to go all the way around to right here. It's going to hit that radius. Okay, and then we're going to flip and we're going to go across here. It's like a game of connect the dots. And I won't lie, has anybody ever used a CAD mouse, a space mouse? Anybody ever seen one of these or used one? Like whenever I do this, like most of the time I'm pretty comfortable just using a regular mouse. But when I'm doing this, I'm having to spin the part a lot and kind of chase the geometry around. I wish I had a 3D mouse up here to do it with. This thing, it's just a little twist and kind of joystick toggle, and it makes it way easier to pan around your part and move around. They claim it's better for your wrist too. So, but yeah, just a small. It's just a $200 mouse. Yeah. But if you're doing CAD all the time, and it's avoidance. Same thing here. We basically want to avoid everything else, right? Kind of flip-flop where we're at here, so we'll just rechain all. And this time I'm going to say, okay, hey, go around this edge. I'll just until I get over here. And once I get it back over to here, we'll give it one more. We'll say, hey, I want you to go up now. Up, over, and we're going to go down the chamfer, across that face, and then we'll go back up the chamfer, across and down. Okay. So there's like kind of how you chase those edges, and you kind of got to do a little. It does take a little bit to do it, but now we're isolating on that island. Okay, and if I change the linking parameter, that's literally all I got to do is change the depth down to this face, 17 millimeters, and there's the roughing for that one. And I would just go around the whole part, one feature at a time. And I told you that I also want to make sure I don't have to recut anything. Okay? So to do that, you know, we've got this pocket here, which is like an open pocket. Right? We've got this area in here that we want to machine. So that's where I could use like that partial chain option. So I could say, hey, take this, copy it, and on this one I'll go in, I'll say, all right, we're gonna get rid of you, we're gonna get rid of you. Machining region, I'm gonna say partial C-plane this time, because I want to stay, I don't want it to try to go up vertical anywhere. And I'm gonna pick, maybe I'm gonna pick, if it lets me. Why didn't it let me pick the top of that chamfer? Apparently it's not going to let me on the partial because it's got the... Huh. Okay, I guess I am going to use edges. It's trying to go up the thing. All the way around until I get back to here. Open chain, and they talked about this in the video about the open chains. We're going to say from the outside. I'm not going to extend it any. I'm just going to give you a preview of what it's going to do. Since that chain's open on that end, it knows this is the blue area is kind of my entry into this slot. Watch this though. I'm going to select the depth real quick. I think it's the same, but 18 on this one. So there's that rough coming in there. Watch if I turn on the rest material I've been talking about. So if I turn that on, that little slot in the center, that's already machined out. So if I turn this on, I say, hey, anything that's been done in this machine group that's already gone, recognize that. Like, recognize the stuff that's already, that's what we're doing. We're basically saying, hey, machine anything that's still left and calculate off the previous tool paths. When I do that, didn't change it a lot, but you can see here in the middle, this opened up quite a bit. Like, it's not spending as much time getting through this area. See the more brown in the middle? Because it knows that's like an air region. It's not a big air region, so it doesn't really make a huge difference as far as what it looks like. But it does make a little difference as far as how it affects it. Okay. Any questions about it? How many suppressed the fillets and stuff when they did theirs and did it that way? Anybody? How many figured it out just by doing it this way? How many just got it to look like it's cutting right but don't know for sure if it's cutting right? Hey, be honest. That's fine. Trust me, I talked to the other class about something. Like somebody asked me about their sweeping arm. Okay, you're gonna have to mess some stuff up in here to learn some stuff, because there's gonna be times where I forget about all the mistakes I've made and I forget to share them with you. But I had somebody hold their sweeping arm up and showed it to me, and his sweeping arm. This is my wrench. This is the one I made whenever I was a student. Held up his sweeping arm, and he had cut like the first 1/8 inch down. and then wanted to talk to me about like, okay, I'm gonna flip it over to do the other side now, and I was like, well, you've already scrapped the part. Not necessarily. It's not scrapped. It'll still work, and he can finish it the way it is. But the problem is now, whenever he does the other side, and he machines down because he's already cut the contour, and then he had it kind of set up to where he was going to machine down to that contour, you're going to have a parting line. So one of the things I always try to make sure to recommend, and as many times as you can, to avoid parting lines, don't try to meet in the middle of anything. If you can machine all of one wall from one side, that's what you should do. That's why the material's 3/4 by 5/8, so that you can stay in the tall side up, machine the full 1/2 inch down plus a little bit extra, just like the video does, and that way you get a good consistent finish. But I said that, and I'm judging, telling them to do that. But I also wanted to grab this wrench and say, but this is the one I made, and if you want to fill the parting line because I did that the wrong way, feel free. Because when I was sitting where you're at, this is the wrench I made. It's a cool wrench. It's got some 3D features, and it's got a little Pringles guy that was the instructor I had at the time. That's what he looked like, with a big mustache. But it's got a big old nasty parting line right here, because that, even though I spent time trying to fine tune the offsets in to get rid of it, you can still see it. It's still there. Lesson learned. You know what I mean? Like this was a learning lesson. So. All right. But like I said, with this part, personally, if I was making this part, I'd do just like kind of what I touched on at the end of class the other day. New level. Call it my machine model or whatever you want to call it. I'd copy that thing and I'd paste the entities to that level. I'd come here and all that wireframe that came with it, I'd basically say, hey, let's take that and probably put that over here to hide it out of the way, because we don't want to mess up the wireframe. Okay. But I literally, once that model was there, machine model, and then all of the fillets, if they're not a vertical wall fillet, if it's a fillet between the face and the floor, I'm either suppressing them. Okay, now that was a vertical one, wasn't it? Okay. All these chamfers, I'm suppressing them out. All these fillets, I'm suppressing them out. All these other chamfers and fillets, come on, there it is. Oh, did it come back? This is what we fought with earlier. I think it just decided to crash. All right, so anyhow, let me try this one more time and see if I can not crash the computer again, because I do want to just machine model and call this the wire. So we're going to take that, we're going to select this, copy it, okay. We're going to paste the selected. Hide this guy, we're going to go here, we're going to grab the wireframe, we're going to move it, move selected, and then we'll hide it. There we go. Okay. I'm going to save this file because it's liable to crash again here in a second. Whoa. Go to our machine model. Move the stop op all the way up. So that's, like I said, same toolpath, and this is why I wanted to do this, so I could show you. You saw me chase that edge around. Okay, you watched me chase those edges around. Let me create another toolpath group. Whoa, where are you going? That was weird. Yeah, get out of here. Press features. Okay. I've got to know, I don't program typically without a print sitting in front of me. So like whenever I'm machining something, I'm looking and seeing like details about fillet sizes, chamfer sizes, and stuff like that. In this case, I don't have a print. They might send me a model and I've got to go back. So if I need to know what this fillet is on this wall over here to make sure I pick the right tool, not a big deal, because I can just go into my levels and say, hey, bring this part back in and slide this one. Let's get off the solid here. Okay, get that unselected. Because I can come in and I can say, hey, analyze this feature. Well, you're not going to let me see it. Okay. That fillet's 1 millimeter. Okay, that's all I need to know. Go back in my levels. And then if I want to machine that, here's how much easier this is now compared to that. With all this the way it is now, dynamic mill, machining region, okay, outer edge shared, boom. Oop, wrong one, sorry. This one? No. I thought it was outer edge shared. I will just select the loop. Okay, we're going to grab that loop. I thought you could pick one of these and just pick the face of it, but it doesn't want to pick all of it. So we pick that, we tell it okay. Easy enough. We'll say avoidance region. I'll just leave it on loop. I'll grab this edge. Heck, I could grab this edge. I can grab pretty much anything else that represents the part. What do you mean? Pick one that went all the way around the whole thing? No, I didn't. All machining regions have no remaining material. From the outside, machining region, okay, avoidance regions, okay, there it goes, okay, and there you can, click, click, click. I don't have to sit there and try to trace it around. I just went right over the top, pick those edges. Let it generate. Continue, yes. Okay. It doesn't like whenever I do that, does it? just assume I delete those out just because we don't need them even. Rather than suppress them, let's just delete them. They don't need to be part of that model anymore. Why is it not showing us any? Oh, because this is on. And the other toolpath above has already machined it. That was the problem all along. There it is. Sorry. Also got to be careful of that. If you've used the stock rest material, it stays on. As soon as I shut it back off, now we're in here machining this out, getting that all cut out. Okay. All right. Save that. Probably, I'd say most of you have a little cleaning up to do. It's been a couple weeks since we even looked at this. You know, we're enjoying a nice little snow day last week. So, what I want to do now is I would like you to open up from Cam Instructor, and you can share with each other if you need to. So if somebody's got a thumb drive, if you don't have access, but I want to open up this dynamic contour. Okay, the dynamic contour file. While you're sharing files and getting those opened up, I'm going to talk about something else real quick. So those that do have Cam Instructor access, you notice I skipped area mill. Okay. Area mill is similar to dynamic mill, except the dynamic cutting motion is no longer used. What that means is it basically can rough parts just like dynamic mill. The only difference is it is a much more rugged tool movement approach. So it's more like the zigzag type step over, like with the straight over into the next cut and full bore. No easy in, easy outs. It's going to be harder on the tool. I call it the in between. The pocket high speed. You know, the first dynamic tool motion is the pocket tool path, and then utilizing that with the high speed machining trochoidal motion. Still not really perfected. All right. Then they developed this area mill toolpath, probably sometime, I don't even want to guess. Let's see if I can get logged in here. What's going on? What happened? Okay. See if it'll give me versions. So just kind of give you progression. Whenever I started in Mastercam, there was no area mill toolpath. All right, so here we go. (2010) was the first pocket high-speed HSM toolpath. 2012 X6, the area mill toolpath came into play, and probably 19, I'm guessing. 13? No way. 2013, the first dynamic mill. I would have thought it was way later than that, personally.
This was it.
Okay. So this was a game changer. This was a game changer. So these are still here, but they had like kind of a short shelf life. Meaning they came, it's like, oh, this is really cool. Well, then the next year they were like, we figured out a way to make it a little better. And then 2 years later, we figured out a way to make it even better yet. And this toolpath has consistently gotten better over the last several versions of Mastercam. I think version 2019, okay, which just to kind of give everybody, these were not done by the years. So X7 was basically version 17, then it was X8, X9, and when they got to basically what would have been XX, or whatever the Roman numeral is for 20, they switched over to the year Mastercam 2017. So in 2017 was when it switched to the Mastercam and then the year rather than the version numbers. Okay, so that was when things changed. So smart pocketing, high-speed machining for any shape. Let the toolpath manage the physics. The big thing about dynamic mill is it is going to improve it may machine the part apples to apples at the same metal removal rate as the area mill. The area mill actually could machine it a little faster if you get really aggressive with it. But your tool life, because of the tool radius, minimum toolpath radius entry and exits, and not those super aggressive in and out of the cuts, your tool life will increase considerably. If you cut soft butter-like material all the time, it ain't gonna make any difference. Okay, this is for the tough stuff, for the hard stuff. Okay. All right. Does everybody have this guy open? All right. We're going to take a look at it. If you would, just right-click on the dynamic milling up here and create a new toolpath group. Okay. Just create a new toolpath group. You can name this the in-class walkthrough or whatever you want to call it. But I want you to take toolpath 6, which is the dynamic mill rough. I want you to copy and paste that down here. Okay, so I took toolpath 6, which is the dynamic milling of the outside of this part, and I want to paste it right here. Okay, so one of the things I always like to do when I'm machining, I always like to kind of be forward thinking. What's my next step going to be before I invest a lot of time in this step? Do I have a good progression to the next roughing, finishing, whatever it is that I need to do next? Is this the right next step? You know what I mean? Trying to plan out accordingly. Whenever I first went to industry, I worked with a mentor for a while, and he would do it like this. He would sit on his laptop at the machine programming parts, and he would program one step at a time and cut it. His name was Rich. The guy is extremely successful, has a shop up in the Chicagoland area, then he had a shop down here in Southern Illinois for a while, and years and years of machining experience, and very successful, lucrative. Probably, I think his shop up there has 40 to 50 machines in it. He does well. My problem with Rich and I, where we didn't see eye to eye, was there were multiple times where I was doing it his way, and we got 3 or 4 steps in, and then realized, oh shoot, we should have done this before we already cut that. Where in my digital, like I said, he's old timer. He taught himself CNC. He didn't know anything about Mastercam. He used Gibbs Cam, different software altogether. But in my brain, because of what I had been exposed to in school, was why wouldn't I want to get this thing completely verified here before I ever make the first chip out there? Sometimes there's parts that you don't have to worry about that on. You know, it's so basic you can just go to town on it. I've got 3 parts that I'm going to make this week that are very simple parts. 2D, couple pockets, couple holes, machine the profile. I will probably program them as I go. Cut a part, make sure it's good, go to the next part. But like, when I'm machining a part like this, no, I'm going to verify everything's good before I'm going to have to think it through, because I got to think about how I'm going to hold on to something that's that complex, and I got to make sure I don't machine away the material that I need to hold on to get to the next spot. Like I said, if I machined all that outside first, well, and then I realized that I got everything done, but I don't have enough material still to hold on to flip it over and do the other side, scrap. 1 inch thick, 10 inch by 10 inch piece of material. You know, $100 piece of material, probably in aluminum. What if it was Inconel? You know, what if this was some kind of aerospace bracket that I'm making out of some type of composite that we're not even allowed to know the acronym for? Space metals. Okay. But anyhow, that's why I like to do it, because I'll look at it in backplot right here, and I decide, okay, this is my roughing. I'm roughing it with this great big 2-inch shell mill. It literally, if you look in the toolpath, it's a 2-inch end mill. I've never used a solid carbide 2-inch end mill personally. They do exist, but I've never got to use one. I've held one before at IMTS, but I've held a 4-inch solid carbide end mill that you could barely lift one time up there at IMTS. They had, I think it was in the Kennametal booth, or one of the big tool manufacturers had one. Okay. But I look at it like this, and I look, okay, that's my roughing. I can tell that there's material on the edges out here, but also I can see there's a considerable amount of material where it couldn't get into those concave corners. So, that being said, this is where the dynamic contour would be used, not the regular contour. You know, I've said it a lot, and I'll continue to say it probably on repeat until you guys get tired of hearing it, but there are a lot of ways Mastercam can do everything, but some of the ways are better than others. I could use the dynamic contour for finishing everything, but you're going to notice the dynamic contour is always going to add an extra pass, because it is made to remachine or finish the roughing that the roughing tool couldn't get to, and then finish. Where a regular contour toolpath, I can just do one finish pass. If everything was rough to 20 thousandths from finish size, I could just come in with one regular contour toolpath and finish it out and keep it simple. I don't have the other parameters I got to set. Let's go into this toolpath here. Okay. And let's start out. I do want to leave the speeds and feeds alone right now. We're going to talk a little deeper about that kind of stuff here in a little bit. But we're using this 2-inch flat end mill. Cut parameters, right now it's approach distance 0, offset, no extra offset. We're pretending this block's square already. 25% step over. Stock to leave, it's leaving 20 thou. We're going to drop that to 20, which would be 1% of the 2-inch cutter. Let me talk about that right now. I was going to wait till we do the inside, but we'll just do it here. That's also a spot where I'm thinking forward. I'm not leaving, if I'm not going to finish it with this 2-inch tool, do I want to leave 1% of the 2-inch tool for the finish pass? Or do I want to leave 1% of whatever I plan to finish it with? Whatever I'm going to finish it with. So in this case, I'm going to come back in and finish this outside with a 3/4 inch end mill. Okay. So I'm going to do 1% of the 3/4 on the wall. Then I get asked the question, and I'll just jump right to it, because sometimes it doesn't get asked and I got to bring it up anyhow. Well, yeah, but if you leave the same amount of stock in this pass as what you're going to do in the finish pass, won't the roughing pass get moved into the part too? No, because there's no cutter comp. This is Mastercam is posting out straight centerline geometry for the roughing. No matter what number I put in the tool radius offset at the machine, this toolpath doesn't move because there is no cutter comp. It's basically, there's no option to change it. It's always in computer mode. The only way to move this toolpath is right here. Can't do it at the machine. Change the geometry or change the stock to leave. Okay. We'll go to our linking. We'll give it our values here. We'll tell it 2 inches above. We'll set the depth. Looks like it's already set, but I'll double check it. 5/8 deep. Yeah. Okay. So set those. You should be able to check mark out. And it'll make those little subtle changes we just did to that toolpath. Okay. Now, I'm going to go back into it for just a second because I want to remind, it's been 2 weeks. We had a couple things here that I had like a rule that's not like a law, but it's a rule that I work by because of the fact that if I do it consistently across all toolpaths, I never have like things where I overlook something because I stay consistent. One of them is that minimum toolpath radius. 10% or 10% or a 30-second, whichever's larger. 10% or a 30-second, whichever one's larger. And then 1% of my finish tool on the wall. Okay, we want those two things to be consistent. All right. Okay. Now, let's put a finish pass on this thing. We're using the dynamic contour. So we'll pick dynamic contour right here. We'll say we want to pick the machining region. Notice how this is all grayed out because this isn't roughing anymore, so none of this stuff's going to come into play. We're just going to finish whatever we select. Direction matters. We're going to climb mill, comp left, so we got to go clockwise. So when we pick it, let's say I say share, okay, boss. You know, I'm going to pick boss here and I'm going to pick this floor. It'll grab that boss. Notice it puts the arrow right there. I'm going to move it around to this side by hitting the F key, moving it forward. And I want to make sure that the direction is correct. Okay, I want to make sure that it's going clockwise so that I'm climb milling around that outside. Personal preference is I start on a straight wall. I don't like to start in the middle of arcs. I like to start on straight walls, so I'm going to put it right there on the right side of the part. We'll hit OK. And we can hit OK here. I said we're going to use the 3/4 flat end mill for this, so we'll pick that tool. Cut parameters. Well, what do we want our step over distance to be? Well, this is basically like what's the roughing step over. Remember, this is going to come in and clean out the areas the other tool couldn't get into, like those inside concave areas. So I'd say 25% here. I'd still say you can do at least 25. Stock to leave on walls. Well, I'm going to leave my 1% here. And that's where I get people confused because they go, wait, you're leaving the same amount on your roughing and your finishing. This is the only one that's going to have the cutter comp option, the tool radius offset it to cut it in, to bring it into size. The other one will not move. Okay, there's no cutter comp on the other toolpath. There's no option for a finishing toolpath on the dynamic mill. It's a roughing only toolpath. Okay. Now here's the contour wall. This is the parameter that ties to what I said about my rules. Radius of the tool that shaped the stock. Well, we used a 2-inch tool to shape the stock, so that's 1 inch. Minimum toolpath radius that shape the stock. 10% or a 32nd, whichever's larger. So if I do 0.1 times 2 inches, because it's a 2-inch cutter that we roughed it with, 200 thousandths was the minimum toolpath radius. It does not always pull those in automatically. I think it's doing it because the stuff that was already in the file had it above, and it's modal pulling those in. Normally, you've got to put those in. They're not there already for you. And then the stock thickness. How much did you leave on the walls? And we're going to tell it we left 1% of our finish tool. It rounds it to 3 decimal places. Please don't let that drive you nuts. I've asked Mastercam, why do you guys have this? Like our CAD cam is set up to 4 decimal places, just like our machine processors are, our machine definitions are. But for some reason on these tool paths, it rounds it to 3. It'll be okay. We're not going to be comping in with this to get it within a thou. We're going to do that out there as we fine tune the tool radius at the machine. Finishing, we come here. This is where we can see, hey, this is a 7.5 thou finish pass. See, it rounded it again. I don't know why it does that. I can tell it, hey, I want you to use wear comp. I want cutter comp here. I don't have to go to the computer to comp the part in. I want to be able to do it at the machine. Little review. Computer means you have to go to the computer to make the changes. Change the numbers on the stock to leave. What's control mean? What do we have to do if we put it in control? You got to put the radius of the tools in the tool radius page. So how we work now, everything's in where that you've ran up until now and are going to continue to run. That's why they can be zeros. If you post something out in control and you go out there and they're all zeros, everything that the tool's going to cut, it's going to cut the tool radius further into the part, unless you put the tool radiuses in the tool radius offset page. Let me just give you this little piece of knowledge. It does not look at the diameter in the tool setup page. The diameter in the tool setup page is only there for verification in the graphic screen and the conversational side of the control. Like on the conversational side, I can go in there and just make that diameter smaller and it'll bring it into the part. On the NC side, you have to use the tool radius offset page because that's where the D value looks to. Okay? All right. We're going to use where, that way we don't get in that trouble. We don't have that problem. I don't have anywhere that I go that I use anything other than where. I have completely converted 2 shops that I walked up and like, you guys are doing everything, because they were doing a lot of manual coding still. And when you manual code, control is the better way, because you don't have to sit there and do all the extra math for the center line of the tool and then, to get it, the programs wrote. You just program the edge of the part and then tell the machine, comp this tool out to this radius. But now that we have CAD CAM and it does all that work for us, this is a better way. Lead in, lead out. I'll use my standard stuff here, perpendicular 10 and 25. That's just my preference with my 5% overlap of my tool. Those are just all personal preference things. I know guys that leave those on 100 and 100 and don't mess with it unless they need to make them smaller. I know some people that they've got their Mastercam set up to where it defaults to like 5%, really small numbers. My personal, like on my laptop, when I program it defaults to 10 and 25. 5%, so 0.05 times the tool diameter. So it's 37.5 thou. All right, linking. We'll turn these on. Make them incremental above the top of stock, which is at 0, and the depth. We'll pick our floor here. And then you should be able to hit OK and let it generate this toolpath. mouse over here. Got something weird happening where I can't see my mouse on the other screen. Got it. Still can't see the mouse over here. This is what's funny. Have I showed you guys this? This is these are touch screens, but when I touch this screen over here, it picks up on this screen. When I touch this screen, it picks up on this screen too. I don't know why, but it's weird. Let's see if I can get this to.
Then I have a contour, and first thing I'm going to do is hop into Blender here, our first toolpath.
Huh.
And go to the very, very top here. And from the picture, you can kind of get an idea of what the contours are.
Not sure what's going on with it. It won't bring my mouse back up over there. We're just going to stay to it. All right. There's the toolpath. Like I said, it is a rough finishing, so it'll come down and let's just go like this and let's watch it from above and back plot. It'll come down and kind of pick up anything it thinks there are extra material, and then it'll backfeed and clean out these corners, go around, and it's micro lifting around to there, cleans that up, and then it rapids up, and then it does its finish pass right here. Okay, so it's got some remachining it's going to do. Okay, now it's going to be the toolpath to use if I've got situations like we have right here in these corners that we have to get in there and clean that out. Right? But if I didn't have that, I'd just use a regular contour. Okay. All right. Let's hit OK. What I want to do next, okay, and I'm going to give you about 10 minutes here, is I would like you to rough the 3 pockets in the center. Okay, I would like you to take a few minutes. I'll give you till, and I'm going to give you as long as you need because I can't get my mouse to show up on the other screen. Never had that happen. Dang. All right, well, let's rough those 3. All right, so for this, literally all I would do is I would take toolpath 9, copy it. I'm going to go in and make the modifications, maybe. This is really hard whenever this thing doesn't want to let me see the mouse on this other screen. I'm not going to lie.